Hello again. We're going to talk about oxidation and reduction reactions now, or redox reactions. So if you have a complete ionic equation, that's going to be an ionic equation that shows all of the particles as they truly exist, so separated into their ions. We're only going to break apart aqueous reactants and products. We're not going to touch anything that is a liquid, a solid, or a gas, only the aqueous. You'll know they're aqueous because they're going to have an AQ in parentheses behind them. And so any ions that show up on both sides are spectator ions. They're just there kind of hanging out. Everything else are going to be participating ions. They're going to be the ones actually partaking in the reaction. So an equation that includes only participating ions is called a net ionic equation. So that's going to be the important part. So if we look at this reaction, sodium hydroxide plus copper 2 chloride yields sodium chloride plus copper 2 hydroxide. First thing we're going to want to do is balance this reaction. So take a moment to do that. Okay, and you'll notice that you're going to need 2 in front of the NaOH, and then you're going to need a 2 in front of the sodium chloride. And so now we're balanced. So now what you would do is separate all of your aqueous components into their ionic form. So first one we have is sodium hydroxide. So sodium forms a +1 charge plus hydroxide, which forms a -1 charge. Now you have this 2 here in front. Okay, that 2 is going to be distributed to the ions that it is in front of. So that means we're actually going to have 2 sodium plus 2 hydroxide. All right, continuing on down the line. Plus, we have copper 2 chloride. It's aqueous. So we have our copper, which is going to have a 2+ charge, plus our chlorine, which is going to have a -1 charge. That takes care of our reactants. We've separated everything that is aqueous into its ionic state. Now we can move on to our products. So yields. We have sodium chloride. Sodium is a +1. Chlorine is a -1. Again, here we have this 2 in front, so we're going to distribute that 2 to our 2 ions. So that actually makes us have 2 sodium ions plus 2 chloride ions. Moving on to our next product. Notice that this is a solid, so we actually cannot break that apart. So we're going to leave it as it is, which is CuOH2 solid. Okay, once you have your ionic equation here, you're going to go through and you're going to cancel out all of these spectator ions. So anything that shows up on both sides, you're going to cancel out. It has to be identical. They have to have the exact same coefficient. They have to have the exact same symbol. They have to have the exact same charge. So we're going to start with our first one here, which is the sodium. And if we look at our product side, we do have 2 sodium plus. So we can cancel that out. 2 hydroxides for a reactant. We do not have a 2 hydroxide for the product, so we're going to leave that alone. Copper 2 plus for a reactant. We do not have a copper 2 plus for a product, so we're going to leave that alone. Chlorine. Oops, I forgot to put the 2 in front of the chlorine there. Sorry about that. If you have a subscript that's here, that's going to get redistributed as a coefficient when you write it in the ionic equation. Sorry about that, I did forget that part. So we have our 2 chlorides that are going to cancel out, and that takes care of everything. So now that you have your complete ionic equation, you're going to rewrite it as your cleaned up net ionic equation. So you're going to start with the first thing here, which is our 2 hydroxides plus our copper 2 plus yields copper 2 hydroxide solid. And this reaction should make sense if you look at the charges. 2 times -1 is -2, plus 2 is 0. So our charges work out. We have 2 hydroxide groups here. Here we have our 2 hydroxide groups. 1 copper, 1 copper. So mathematically this equation is balanced, and that is our net ionic equation. So moving along here. So an oxidation reduction is going to occur when electrons are transferred from one atom to another. So here we have a complete reaction. Let's break this guy down into our ionic. So our 2 potassium bromide are both aqueous. So you would get 2K plus 2 Br negative plus, now because chlorine is a gas, we're not going to touch it, so Cl2 gas yields, our potassium chloride is aqueous, so we can go ahead and separate that into our 2 potassium plus our 2 chloride plus, now bromine again is a gas, so we're not going to touch it, so Br2 as a gas. Go through and cancel out the things that are the same on both sides. That's going to be the potassiums, and that's it. So your net ionic equation is going to leave you with the 2 bromide plus chlorine yielding 2 chloride plus bromine. Now, the products are in a different order, but it is the exact same thing that we have written. So what essentially is happening is the chlorines are stealing electrons from the bromide to become chloride ions. Notice that the chlorine here doesn't have a charge, but the bromine does. So the chlorine is going to steal those electrons to now become chloride. The bromine is going to have to do something. It doesn't want its electrons just taken away like that. So it pairs up to make your bromine atom molecule. So if you lose electrons, that is called oxidation. Loss of electrons is oxidation. If you gain electrons, that is reduction. Okay? So a couple of ways to try and remember this. Leo the lion says grr, Leo, lose electron oxidation. The lion says grr, gain electron reduction. Or you can remember oil rig. Oxidation is loss, reduction is gain. Oil, oxidation is loss, rig, reduction is gain. Memorize it any way you want, but know that if you lose electrons, it's undergoing oxidation. If you gain electrons, you are undergoing the reduction part of this pair. So if we look at this reaction, we have 2 sodiums plus some chlorine gas, and that's going to give us 2 sodium chlorides. So can't break apart your solids. 2 Na solid plus Cl2 gas yields, this is aqueous, so we'll get 2 sodium ions plus 2 chlorine ions. When you separate these out, you can break them into what's called a half reaction. So sodium is the one losing electrons, okay? You went from being a compound over here to having a positive charge. So it is the one being oxidized. Now when you write a half reaction, you have to keep account of those electrons. So we had our 2 sodium go to 2 sodium plus. So to make the product side of our reaction equal 0, we have to add those 2 electrons here. So that 2 negative plus 2 positive equal the 0 charge that we have occurring here. So if the sodium lost electrons, that means that the chlorine had to have gained electrons. So chlorine gained electrons. Now, these 2 electrons didn't magically just appear. They came from sodium. So we need to account for them when we write the half reaction for chlorine. So here's our chlorine as it's written up here. Here's our chlorine. And then we have our chlorine ion over here on our product side. This is a negative. There are 2 of them. This is neutral. So to account for that, you have the 2 electrons here. So these 2 electrons in this whole reaction didn't disappear. They've just traded who they're really hanging out with. They went from the sodium, who lost those electrons, to the chlorine, who gained the electrons.